All right, folks, we are back and we're continuing in 1.7. So we just looked at translation. So again, shifting graphs up, down, left, and right. Now we're going to look at reflecting graphs. So there's two major reflections we're going to be looking at. So we have reflections in the x-axis and in the y-axis. So again, looking at what happens with the original parent function, we can see that a reflection in the x-axis involves negating that parent function in its entirety. So the negative's all the way out in front. But if we want to reflect in the y-axis, now we only have to negate just the value of x inside of that function. So again, it can be a little bit tricky depending on the functions, but let's see what we can do. So this first example involving reflections, we have a few layers to the problem. It says we want to identify the parent function, describe the sequence of transformations from f to g, sketch the graph, and then use function notation to write g in terms of f. Okay, so we got a lot going on for these problems, but let's see what we can do. So for A, the parent function. So if we kind of look at the whole picture, we can see that squared sticks out like a sore thumb. So that's probably our parent function. So f of x equals x squared. Okay. For B, what transformations are going on here? So remember, when we are affecting the value of x with a plus or minus something, that's a horizontal shift. So we know it's going to go to the right 2 units, but now this negative out in front, what is that doing? Well, let's cheat and look up here. Remember, when there's a negative in front, that's a reflection in the x. Okay, so we have that and that. Now we got to sketch it. All right, so we have a nice blank graph here. So we want to shift it to the right, and we want to reflect it in the x. So normally we have just our parabola that goes through the origin, but now we want to shift it to the right, so we know that that origin spot's going to get shifted to here, right 2, but then we want to reflect the whole thing down. So instead of coming down through, we want to go up through. Now if you wanted to be really careful and plot some points and stuff, you could, but we're just doing a sketch. Now we could figure out where the y-axis is, or the y-intercept is, but hopefully you kind of remember how to do that. So our graph should look something like this. Again, not a perfect graph, just a rough sketch. So again, where does it hit the x-axis? Where does it hit the y-axis? And kind of fill in between. So now the final part of this was writing the function in function notation. So g in terms of f. So they want g of x equal to, so again, we have to use this to kind of help us guide us. Now, if we just put f of x minus 2, well, we're missing part of the transformation. So really the only other step we're going to do is just put a negative in front of that. So negative f of x minus 2. And that should be it. All right, let's do it again with a different problem. So we got A. So what's our parent function going to be for this one? Yeah, that cube sticks out. So f of x equals x cubed. B, our transformations. Okay, so we got a 1 minus x. Now, a common mistake students make is they see the minus and they see, so they kind of say, oh, I know it's a transformation, it's a reflection in the y-axis, right? Because it's not out in front, it's affecting the x, so that is true. We do have a reflection in the y-axis. But where students make mistakes is we know there's also a shift. but is it to the left or is it to the right? Now, if you tried to rewrite this algebraically, you would get negative x plus 1 cubed. Now, looking at that, you see that plus 1, so you hopefully are thinking to the left 1 unit. But unfortunately, that is not correct. It's not shifted to the left. And the reason why is because it's not quite simplified enough. And what you would have to do to get it properly, because that positive 1 is affecting negative x, not positive x. So we have to go one more step. Just kind of, we want to almost use a square bracket and then a minus and factor out that negative sign. So if we factor the negative off of the x and off of the 1, we get this. Now we can see that it is technically is a minus 1 that's affecting the x. So this would be to the right 1 unit. Very, very tricky thing that they can do with these. So you got to be really careful with this, rewriting it. You want to know how x is being affected, not negative x. So you've got to do this extra step. Okay, so now that we know what it looks like, let's do it. Now the one thing that you might also be wondering is, well, how should is there a specific order that I should do these? You know, we did the shift and then we reflected it. Is that the rule of thumb? Should I always do the reflection second or should I do it first? Well, when it's left and right, I would go with the reflection first and then do the shift second. I mean, we didn't do it that way here because it was a reflection in the x-axis. But if we had done it in reverse order, it would be the same graph here. Not always the same case when you have a reflection. But let's just see. So we know that it's x cubed, so it normally comes up through the third quadrant and kind of comes through the origin and goes up into the first quadrant. So if we reflect it, it flip-flops it. So it should be coming down through the origin and then down. But we want to make sure we shift it to the right 1 unit. So we're going to have a point here. Our origin point moves to the right 1. And then we have a couple of other key points. And that's about all I'm going to be able to fit. Now again, it's not perfect, but you know, those 3 points usually are in line like that. You know, and you can check it if you needed to. But those 3, you know, so you could do it through the, you know, normally the same idea, just to get a good sketch. So, and then the final step of this one is to do that G function notation. So again, very similar to what we did over here. We just took the negative out in front and we kept the shift inside. So we're going to want f of 1 minus x. And that would be it. So, all right. Let's see what we got on the next page. We got a couple more examples in here, so I think I'm going to save them for the next video. So stay tuned for that.